Static routing. In this video, I'm going to talk about again static routing. In the previous video, I configured a static routing with three methods: with outgoing interface, with next hop IP address, and also outgoing and next hop IP address. In this video, I'm going to talk about the, for example, advantage and also disadvantage of the static routing. And also I want to talk about a new topic. We call it default route. And after that, we can learn many new things about the static routing. The first thing is that what is the advantage of the static routing? Advantage. Okay. As you saw in the previous video, one of the advantage of the static routing is that configuring a static routing is easy. Okay. It's easy and you can learn a static routing configuration only in a, for example, 10 or 20 minutes. And this is because of the static routing is so easy. Yes, a static routing maybe should take many time to configuring. And because of that, we know that one of the disadvantage of the static routing is administration overhead. This means that administrator should himself, for example, or herself, should configure many static routes in many routers. And this is one of the disadvantages of the static routing. One of the advantage of the static routing is that it is easy, and one of the disadvantages of static routing is administration overhead. But static routing has one other disadvantage. What is the next disadvantage? Let me to show you. Look at here. For example, you know that in this scenario we configured a static routing, and now, for example, in R1 we have three static routes. Show IP route static. We have three static routes. The first with the outgoing interface, and the second with the next hop, and the third with the outgoing interface and also next hop. Okay, now assume that in R2, the interface between R2 and VPC2 failed. For example, maybe the interface, maybe the link is corrupted. Okay, and after that, now we don't have the ETA00 in R2. For example, in this scenario, I can turn this interface, turn it off. The conf-d in router 2 interface ETA00, then shut down. Now, I configured the ETA00 with shutdown command. This means that now we don't have R2. The first things that you know is that in R2 now we don't have this interface in our routing table. For example, we can't see 10.0.2.0 now in the routing table because I turned it off. So easy. But what is about the R1's routing table? Look at here. R1's routing table now again has these routes. This means that if you, for example, if you lose one interfaces in another routers, if one route fail, other routers with a static route configuration doesn't understand. And this is not good. For example, in R1, if a traffic from VPC1 again sent to R1, R1 should forward it to R2. And you know that R2 doesn't have any route to 10.0.2.0, okay? But R1 doesn't know about it. And after that, R1 should forward the traffic to R2, and this means that we waste the waste of the bandwidth now is occurring, and also maybe other traffics that can go that can send from these links is has some limitation about bandwidth. Okay, and this is not good for us. And finally, we can say that one of the other disadvantage of the static routing is that static routing is an offline method, not online method. This means that, for example, if you have a failed link, a failed network, you should configure all of the routers to remove that route from the routing table. And this is not good. In dynamic routing, when the link between router 2 and VPC2, for example, failed, all of the routers automatically remove that routes. Okay, and this is so good. But in static routing, the routing is offline. This means that when you lose one of the interfaces, one of the links, you should configure with no command, no IP route, for example, in all of the other routers in the network to remove that network. And this is not good. One of the disadvantages of the static routing. And the next thing is that static routing is so error prone. This means that if you configure one of the routes incorrectly, okay, the traffic can go to other networks, for the other sides of the network, and this is not good because everything related to the configuration of administrators, and also you know that because of administration overhead, and also maybe administrator configure some routes with error, we lose the connectivity, and this is not good. Other disadvantage of the, for example, static routing, when you learn about the dynamic routing, you will see that we don't have any administration overhead. The routing is online. This means that when, for example, you lose one of the links in all of the routers, that subnet should be removed and will be removed. And also the dynamic routing isn't error prone. Because of that, we should use static routing in a small scenarios, for example, the enterprises. And also we have one other advantage in static routing, because when you enable a dynamic routing protocol for dynamic routing between router 1 and other routers, some packets should be sent between two routers. For example, you are using one of the routing protocols, we call it OSPF or EIGRP, or for example RIP. That routing protocol should send some packets between routers, and these packets maybe waste the bandwidth of the link. Okay, but in static routing we don't have this overhead, and this is an advantage for the static routing. No overhead. Okay, so easy. Now you know about the disadvantage and also advantage of the static routing. Finally, as a result, we should use static routing in small enterprises and maybe for some other special reasons. But normally we are using dynamic routing with routing protocols, and we have many benefits to static routing. I will talk about the dynamic routing in the future videos. Very good. Now, what is the default route? For understanding the default route, first you should understand the one important rules in the routing. We call it longest. This is a rule, longest prefix match. Rule, longest prefix match. Let me to talk about the longest prefix match. This is the rule. This is an important rule in the routing. But how we can use this rule? First, we should understand this rule. Look at here. Assume that we have a router. In our router, we have a routing table. Okay. In routing table of router, we have three routes. For example, the first route is 192.168.10/24 serial 10. This means that if you receive a traffic for 192.168.10/24 network, use the serial 10 as an outgoing interface. And the next rule is that 192.168.00/16 serial 11. This means that if you receive a traffic from the 192 to the 192.168.00, please send it from the serial 11. Forward it from serial 11. And the next rule is 192, for example, 000/8 serial 12. This is the next rule, and this is our routing table. Now, one question now is available for us. If we receive one traffic from the to destination of 192.168.110, okay, this router should forward this packet from which interface? Okay, let me to talk about this. Look at here. This traffic receives in the router, and router should check the destination IP 192.168.110 with its routing table. Now, in the routing table of the router, as you can see, we have three routes. These routes now first